a note packet. So we're going to be starting on page number 8. I'd also recommend have your reference tables handy. We're going to need to look up some atomic masses. And you will obviously need a calculator, as always, for this unit. So we are finishing off the note packet, which means we are finally at the end of this unit. So your test on all of this, expect to be either on, if you're a cohort A person, it'll be on Friday, November 20th, or Monday, November 23rd, okay? So our topic for today, if you scope it out on the top of page 8 here, types of formulas. So up until this point, when we've been dealing with formulas, we've been dealing with the middle kind, molecular formulas, the actual makeup of a molecule. It may be a multiple of the empirical formula. We'll talk about that in a moment. But like when we talk about, glucose, C6H12O6, that's what's actually in the molecule. When we talk about magnesium chloride, MgCl2, that's what's actually in the molecule. An empirical formula then is the, I have my key on the right page, doesn't it? Here we go. Simplest ratio. The most reduced form. So if we take that example of glucose, the molecular formula, what's actually there is C6H12O6. To get that into an empirical formula, what you're going to do is you are going to take the molecular, C6H12O6, and you are going to divide those subscripts by the greatest common denominator, which in this case is going to be 6, right? So my empirical formula would be C1, which we don't have to actually show the 1, H2O1, but you don't have to show the 1. So CH2O, that is the empirical formula. It's the most reduced. It just gives you the ratio between the atoms that are in that compound. The other type of formula that we have, you can see off to the right-hand side of the page, is a structural formula. It shows the arrangements of atoms in the chemical structure. So the structural formula for here, this is what glucose actually looks like. At each of these junction points of this hexagon here, there's actually a carbon. When we get to organic chemistry, we'll talk more about how to draw molecules and that type of thing. But you have to imagine you have a hexagon where 5 of the points of the hexagon are carbon atoms, the 6th point is an oxygen, and then you have stuff hanging off of all the little carbons that are in this hexagon. So again, we will eventually talk more about how do you get to the structure. For right now, though, we're really dealing with these two, the empirical formula and the molecular formula. So some comparisons. How are you going to recognize if something is an empirical formula? It's in the most reduced form. You can't reduce it any further. So like CH, it's a 1-to-1 ratio. That ratio can't be reduced. It's empirical. This would have a molar mass of 13, right? Carbon is 12.0, hydrogen is 1.0. Acetylene is C2H2. You can reduce that down, right? It's a 2-to-2 ratio, which would be a 1-to-1. So this would be a molecular formula. And the molar mass for this, well, C2H2 is like twice the amount of CH, right? So what I could do for my molar mass over here is just take the molar mass of CH and multiply it by 2. So it'd be 26.0. Benzene is C6H6, so 6-to-6 ratio. You can reduce that down to 1-to-1, right? So this would be molecular because it can be reduced. And this benzene is 6 times the amount of the CH that we saw up at the top. So if I want to find its molar mass, I could just multiply. Gives me 78.0, okay? Now, could you just take inventory and figure out the molar mass the way that we've been doing it? Yes, absolutely. But if you know the molar mass of the reduced version of the empirical, and you know how many times greater the molecular formula is, you can kind of take a little bit of a shortcut. Formaldehyde, it's a preservative, used to be used in embalming and that type of thing until they figured out it was carcinogenic. So it is CH2O. So that's a 1-to-2-to-1 ratio. That is the most reduced ratio you can get. So that is empirical. It has a molar mass of 30. Acetic acid is the fancy chemical name for what's in vinegar. Why vinegar is acidic is because it has acetic acid in it. The formula for this is C2H4O2. Okay. So it's a 2 to 4 to 2 ratio. You can reduce that down, which tells me that this is molecular. I can't spell this morning. There we go. Its molar mass it's twice the amount of formaldehyde, right? So it's 2 times 30 would be 60. And then C6H12O6, we've seen this a few times at this point. This is glucose. It is obviously molecular. You can reduce it down further. It is 6 times the amount of our formaldehyde. So 6 times 30 is 180.0. Technically, molar masses should always go to 10th place, right? So there's that. All right, so that is the difference between empirical and molecular. So we're going to do some practice problems. Actually, let me... All right, guys, so before we move on, I actually decided to flip over to part of the worksheet that I had assigned as well, can't talk this morning. As well as watching this video, you have to complete this worksheet, which has 4 questions on it. I decided to flip over here. We're going to do the first question together, which means after you finish this video, you are going to do the other 3 problems, okay? So the problem number 1 says a compound was analyzed and found to contain 0.7 grams of hydrogen, 9.8 grams nitrogen, and 33.6 grams of oxygen. What is the empirical formula? Now remember, an empirical formula is a mole ratio. So I need to, first of all, convert each of these into moles. So I'm going to do my hydrogen first. How do you get grams to moles? You need to know the molar mass of the element, right? Hydrogen has a molar mass of 1.0 grams per 1 mole. So 0.7 grams of hydrogen times 1 divided by 1 is 0.7 moles of hydrogen, okay? I'm going to do the same thing with the next problem. I have 9.8 grams of nitrogen. I have to plug in my molar mass. So 14.0 grams per 1 mole. So in my calculator, I have 9.8 grams divided by 14.0 grams per mole gives me 0.7 moles of nitrogen. And you'll notice the other thing I'm doing is I'm labeling these not only with moles, but moles of what? So my last problem here, I'm going to plug in molar mass of oxygen, which is 16.0. 1 mole goes in the top. Mathematically, I have 33.6 grams. 33.6 grams divided by 16.0 gives me 2.1 moles oxygen. All right, now to get these into the nearest, excuse me, into a whole number ratio, because that's what you need for an empirical formula, right? You're not going to put H.7, N.7, O, 2.1. You need to get these into a whole number ratio. So what you're going to do, you're going to take each of these mole values and you're going to divide them by the lowest mole value. Now in this case, my hydrogen and my nitrogen are both the same. They are both 0.7. Do this to each. Divide each by the smallest number of moles. So 0.7 moles hydrogen divided by 0.7 gives me 1 mole hydrogen. 0.7 moles nitrogen divided by 0.7 gives me 1 mole nitrogen. 2.1 moles oxygen divided by 0.7 gives me 3 moles oxygen. So my empirical formula, HNO3. Okay? So 1 mole hydrogen, 1 mole nitrogen, 3 moles oxygen. Try number 2 on your own, okay? Once we finish with the rest of the video. Okay, and we are back. So getting from a molecular formula into an empirical is pretty easy. You just divide by the greatest common denominator. Getting into an empirical formula, if you know the amount of each element, is reasonably easy. That was the problem that we just did. The last thing we have to talk about is how do you get to a molecular formula if you know it's empirical? And in order to solve a problem like this, you also have to know the molecular mass, which is the molar mass of the molecular formula, okay? You'll have to be given that, and you need to know the empirical formula. So here are the steps. You are going to divide the molecular mass of the compound by the molar mass of the empirical formula. The result will be an integer. Remember, an integer is a whole number, okay? The integer tells you the molecular formula is that many times greater than the empirical formula. So you will multiply the subscripts of the empirical formula by this integer. So let's take a look at a couple of practice problems. Problem number 1, a compound with an empirical formula of CH2 has a molecular mass of 70 U. What is the molecular formula? So the first thing I have to do is find the molar mass of the empirical. So off to the side here, I'm going to take inventory and list how many elements I have. So I have 1 carbon, I have 2 hydrogen. My next step then is to look up the molar masses of each of these elements. So carbon is 12.0, 1 times 12.0 is 12.0. Hydrogen is 1.0, 2 times 1.0 is 2.0. If I add those together, I get the molar mass of the empirical formula is 14.0. So then you take the molecular mass, 70. You divide it by the molar mass of the empirical formula, in this case, 14.0. I am going to get a whole number. 70 divided by 14 is 5. So then I take my empirical formula. Sometimes this is also a good point to draw in those ones, even though they're not really written. And what you're going to do is you're going to multiply each subscript by that integer. So my formula, C5H10. Okay? And that would be my answer. To do one more together, let's take a look at number 2. Vitamin C has an empirical formula of C3H4O3 and a molecular mass of 176 U. What is the molecular formula? So my first step is to take inventory. My second step is to look up the molar masses of each of these. So carbon is 12.0 times 3 is 36.0. Again, make sure you're always keeping those to the 10th place. Hydrogen is 1.0. There are 4 of them, so that would be 4.0. Oxygen is 16.0. There are 3 of them, which is going to give me 48.0. Add those together. It's going to be 88.0. Okay. My next step then, take the molecular mass, 176, divided by the molar mass of the empirical, 88.0. I'm going to wind up with 2. So I take my empirical formula, C3H4O3, and I multiply each of those subscripts by the integer, which gives me C6H8O6. That is horrifically written, but you get the idea. All right, so I'm going to stop there. Now, there are obviously 3 more practice problems in this note packet for you to take a look at. I will post the answer key to these last 3 problems. So I would recommend maybe take a look at them, make sure it makes sense where everything's coming from. Can you do them? These are absolutely the types of problems you can expect to see on your test on either Friday or Monday. And then your other asynchronous work, guys, is to finish off the rest of that worksheet, calculating empirical formulas. We did number 1 together. You need to do number 2, number 3, and number 4. And then turn this in Cami. Okay? If you have questions, as always, reach out, and I will talk to you soon. Bye.